Well, hello everybody and welcome. You're watching OBanby and today you're gonna get Dockerized. So, if you're a software engineer in this day and age, you must learn Docker. It's almost a prerequisite to everything else, right? It will change your life. So, let's get right into it. But the reason why you should watch this series is because if you're anything like me, you like to understand how things works in depth. And that's exactly what we're gonna do. So, click the subscribe button somewhere below so you can see more of this content. And let's get right into it. So what is Docker and why do we need it? Okay, let's get to a whiteboard. Are you a really software engineer if you're not using a whiteboard? I don't know. Okay, so history lesson. People a long time ago, they would try to ship code in a very inefficient way, right? But they had to work with what they had at the time. So they would write code in isolated machines, and then afterwards they try to share it to each other, right? Using any transferring medium, right? Whether it's like giving you a CD, floppy disk, or even USB. Then people realized that this is just not good, and the networking stuff got better and better, so people start creating FTP servers where they share their code using just file sharing servers, right? And then quickly they realized that this is also not scalable or as good anymore. So they created source control systems, right? And there's many source control systems, but that's not the point. We're not going to be talking about that. So essentially, source control systems has improved the way people write code and share code in a very good way. But then the problem happened when people would try to get the code from a source control system and try to run it, and it just doesn't work for you. So they would reach out and be like, hey man, your code is broken. And they would be like, well, no, it's not, because it runs on my machine. You're probably doing something wrong, or go buy another computer, or go fix your libraries and stuff like that. Create a lot of hassle, right? And then worse is that they would try to put it in production after developing and spending so much time, money, and effort in it, and it just doesn't work as expected, or they find weird production bug that only happens in a specific type or version of the distribution that you're running, right? Not cool, really not cool. So they said, okay, let's fix it. What are we gonna do? We gotta create a virtual machine. What is a virtual machine? It's essentially a thing that talks to your computer and abstracts your operating systems. What the hell does that mean? So let's look into a diagram. Maybe that would explain it, right? So yeah, you gotta start with a box. If you go to an interview, always starts with a box. If it doesn't start with a box, you're not getting the job. It's not science, by the way. I'm just talking out of my ass. All right. So right here, you have your hardware. Cool. Then you have your operating system. Linux, Mac OS, Windows, yada yada. Right? And then you have here a virtual machine program. Software, right? Like VirtualBox or there's many out there. Just let's call it VirtualBox for now. And then you start looking what this actually does, and essentially, I can't use this color, let's use this one. This is just a box here. So this is like as if you're running two different virtual machines, right? So here you'll have an entire version of your operating systems. Here you'll have your libraries. And here you'll have your application. And then you'll have another virtual machine that's running maybe a different version of your application, another library, app. And we're gonna label these as version 1 of your app and maybe version 2, right? So this has fixed a lot of things, because now people can just say, okay, use the virtual machine with this particular OSI image, which is essentially that box, right? So they say like use the virtual machine with that image and it will work. And indeed, it does work. And people created automation software to help with this. Like you have Packer, maintained by HashiCorp, that allows you to like build your OSI images and to share them easier and stuff, right? So cool, life is good and dandy. So what the hell is Docker and why are we still here? Okay, well, every time you try to share an OSI image, you're taking an entire copy of your operating systems. You're talking gigs, right? So this means that it's a slow process that in development, it means that you have to take a lot of time to spin up and hell a lot of resources. If you ever did computer science, chances are that you've ran into creating a virtual machine and running a virtual machine, and it's a pain in the butt. So not cool. So people said, let's do better. But before we do that, let's just label a few things because that will make the next diagram a lot easier. So this is your OSI image, which is essentially how virtual machines are packaged, right? This is an entire version of your operating system or whatever operating system you're running, but it's a copy, an entire copy. Full OS. Then you have virtual machine software like VMware, and then you have your actual operating system, well, hardware is pretty much self-explanatory, isn't it? Cool. So people said, no, this is taking too much time. This is just not efficient. We should totally do better, right? Why do we need an entire operating system copy every time I want to run my application? I just want to package it in a way that my operating systems already understand. I just need different libraries and stuff. We must do better. So came Docker to the rescue. So what Docker did essentially was the same exact explanation I said earlier, right? Where you don't take an entire copy of your OS. So how did they solve it? They put the hardware, which is already there. That's your amazing operating system. And let's not get into war, which one is best. And then they have the Docker daemon, which we'll talk a lot more. We'll talk a lot more about it later. And then you have, let's use a different color. And then you have your container, which just have a little bit of the libraries you need and has your application. Okay, so if you can see from this diagram, there's a significant, it's a significant decrease of resources because you no longer have to copy an entire operating system. You're only using the underlying operating system, this one right here, and sharing it between applications, but creating that isolation in the file system, in the network, in the IP space. You're creating enough isolation that these applications do not conflict, right? So that was a very significant improvement, and that's why Docker was created, right? So it's important to know though, let's label these ones. So this is your underlying operating system. An application. And this is these are called containers. And containers is the package that, like, how you package your applications in the Docker terminology, right? Same as OSI images are how you create an OSI image in virtual machine. It's pretty much the same concept. Cool. So to summarize, what is Docker? So Docker is a software that allows you to package your application and ship it easier, right? It shares your underlying operating system and create isolation for your application. And that's pretty much it. So that's it for the history lesson and why Docker was created. In the next one, we're going to be talking about how to use Docker, how to install it, and what is the Docker daemon and what Docker architecture consists of, right? Anyway, see you in the next one. Bonus material though. Here we said the VM software, right? What is that called? And you can skip that part, it's not really that important, but it is good to know. So this is called a hypervisor, and essentially all what it does is that it translates one operating system's command from your OSI image into something that your operating system, your actual operating system, can understand. So it's just a translation service essentially, right? Of course it's a lot more than that, but this is in a conceptual level what it does. And the Docker daemon kind of serves like a similar behavior, but it doesn't really translate because you don't have a different operating system, but it manages all your packages and manages all your containers. So stay tuned for the next one. See ya.